it was going to be, or it is going to be much better if you are having a pen and a paper next to you so that we can move smoothly with this presentation. I don't know, Doctor, if you can just allow me to give everyone maybe just 3 minutes to prepare themselves, just to have a pen and a paper next to them.
Not a problem.
Yeah, just 3 minutes, guys, and then after when you are done, and then I'm gonna resume with the presentation.
I heard someone say we are ready.
So is everyone ready?
From my side, I am.
Okay, yes, if we are having a pen and paper, it is okay. And then for those that are not having a pen and paper, you can just take your camera on your phone so that when I say take a picture of something, you take a picture of something and then we proceed, right?
All right, sir.
Okay, thank you. Yeah. So, ladies and gentlemen, as it has been alluded by by Dr. Sandile Mtimkulu, today's talk is going to be all about fertilizer recommendations. So I thought it was going to be much appropriate and most relevant if I use this Fertasa book, the Fertilizer Association of South Africa, to make a fertilizer recommendation based on the sample result, the analytical report from 2 laboratories. And then that's how I think it's gonna work out, because I understand that for a kind of this presentation, I can just go online on Google and type how to make fertilizer recommendations and then copy things from the different PDFs of which are not from South Africa. So I think it is very, very much important so that we make fertilizer recommendations based on the guidelines that covers the soils around South Africa so that we can be as precise as possible. Okay, ladies and gentlemen, with me here, I'm having the first analytical report. This report was analyzed in Nooitgedacht Soil Testing Laboratory. I think if someone is having a phone or a cell phone with them, they can just take a picture of the analytical report presented to us or in front of us. So that like when we move forward, we try to analyze this report. Firstly, what we are going to do first thing first is we are going to interpret this analytical report. After interpreting this analytical report, that's when we are going to take steps to make fertilizer recommendations. If I can ask on the house, is everyone ready? Did you take a picture of this PowerPoint?
I did.
Everyone on the house, did you take a picture? Or did you write these values down?
I saw thumbs up, so I think our colleagues did.
Okay, yeah, I think what we are going to do is we are going to, for Nooitgedacht analytical report, we are going to make it sample number 1. And then as I move to this other analytical report, this is an analytical report from Bethal Laboratory. So we can take this one as our sample number B. I understand that on the report, it is the lab number, it is sample A, but this one we can have it as our analytical report number B, right? And then 1, 2, 1, 2. So I believe that everyone has also captured this picture. Then moving forward, if we go back to the first picture of our results from the Nooitgedacht Soil Testing Laboratory, first thing first, if you can check, remember from the previous presentation, I spoke about the most critical components that you should have on an analytical report. I spoke about the issues of soil pH, the EC. Sometimes you'll find exchangeable acidity, your phosphorus, your cations, your clay percentage, and also calculated effective CEC. So right now, ladies and gentlemen, I believe that we are having the report with you. And then if we can check on the report that we are having, can we see that the pH for water is 5.6? Can we see that? Yeah, on your report, not on the slide. The report that you took a picture of soil net reductive soil laboratory testing.
Oh yes, yes.
Can you see your pH? It is 4.6. I mean, it's 5.6 for pH water and then 4.3 for pH KCl, right? So what we are going to do now, we are trying to interpret the pH of the results that we are having from the lab. As you can see on the table here and on the slide, this is the table that is showing us the degree of acidity. If you can check on the degree of acidity, all of us, we can see that our results falls under acidic soils, right? So if we can check, our soils falls under acidic soil. But if you can check, they are at the category of just the optimum range of acidity. It is not very acidic, it's in between, but it is acidic. So it means that back in our mind, we can immediately see that our soil, it is acidic. That's the first thing that you have to do on an analytical report. You have to check whether your pH it is acidic or not, right? And then if now you go back to the picture that you just took on the analytical report, can you see that there is a section that is written ammonium acetate pH 7? You have your cations there. You have your calcium, sodium, magnesium, and potassium. Can you see the value for potassium is 41.68, sodium 12.9. Can you see? Then
Yes,
if you can check, there is one thing that I want you to check. I want us to analyze the relationship. If you can check on this table, on the presented slide, you can see that we are having acidic soils. And then the supporting analysis, if you can check, what is the meaning? The meaning, it says the soils are too acidic, except for tea plantation. And then it means that for other crops, the crops will not be able to grow the way that you want, more especially in terms of suitability because of acidity of the soil. And then the supporting analysis are saying, in most cases, if you find that you have analyzed your soils in the lab and you find that your soils are acidic, the supporting analysis are saying you are likely to get low cation exchange capacity. You are likely to get your calcium and magnesium at a very low level. Can you see? So it means that on our analytical report now, we should keep it in our mind that, okay, the report says the soil it is acidic. Now let's check the values of our cation exchange capacity. Can we see that the values from the picture that you took, you have 273 calcium and you have 46 magnesium. Can you see? Yes, okay, it is fine. Thanks. And then now let's come to interpretation again. Then we have the issues of acid saturation. So in this point, I will just jump this one because like on the analytical report, acidity was not determined, but it is easy. We can still show you calculations on how to find acidity without calculating it. As long as we are having pH and then somehow we'll find a way to work it out. Now let's check on our results. We have phosphorus by the method of Bray 1. Can you see the value of phosphorus is 6.29?
Sorry, Sadiki.
Yes.
I'm sorry to interrupt. When you look at the values here, your cation status.
Yes.
In that table. So that calcium, which is
less than 200.
Less than 200, we're saying it's low. Is that low for all the crops, or what do we mean by that?
Okay, we are still coming on this one. Can you see the tables here? It will explain for the grains, the vegetables, and whatever. So these ones are just the standard norms for any soil. At least if soil contains these elements at this level, at least we can say our soils are not bad. You see, but specifically when we come to each and every crop, remember when you are having maize, maize will require its own phosphorus, and then you go to vegetables. Vegetables will also require their own phosphorus because of, we know that the vegetables as compared to maize or the grains, they do not require the same amount of nutrients. Vegetables, they are very sensitive, they are labor intensive, you have to irrigate too much, you have to also put more fertilizers. Because like if you can check on table 5.2.3, this one, table 5.2.3, you can see Bray 1, grains and vegetables. If you can see on the grains, the phosphorus is classified to say if it is less than 8, you are having low phosphorus. But for vegetables, less than 15. Can you see the difference?
Yeah, I can see the difference.
Yes, you can see that like already. That's why, ladies and gentlemen, in most cases, you find that maize production and also maybe cowpea or dry beans production, they depend, in most cases, we have two scenarios. You can plant maize under irrigation. You can plant maize under rainfall or rain-fed conditions. But with vegetables, you cannot plant the vegetables and say these vegetables are rain-fed, are for rain-fed. You know that you are going to face a disaster. Can you see that already on the table, why the vegetables requires more as compared to the grains? And then the interpretation behind that, the meaning is that, okay, now in most cases, you can see on the deduction, probably they are saying this might be a new land, you see. And then sometimes at some point you will find that we know that each and every soil will contain the nutrient status level. I mean, that particular nutrient level, depending from one soil to another. And we know that the influences might be the issues of the parent material, the issues of the vegetation around that has decomposed to make some of the nutrients to be available in the soil, and the issues of nutrient cycling from those organic materials and decomposed organic materials to organic matter, and then you decompose further to humus. And then now, if let's say our phosphorus, from the results, our lab note reduct, the phosphorus status here, it is 6.29. Can you see that if the phosphorus is, it is 6.29 according to the interpretation of just general norm, you know that your phosphorus is very low. Can you see? Now, let me move forward. Now we have table 5.2.5, indication of approximate optimum soil analysis values for a variety of crops. Now you have different crops here, ladies and gentlemen. You have grains, vegetables, potato, citrus, etc., etc. So in most cases, the values that you see here, these are the values that are required at the top soil layer for the at the depth of 20 centimeter. These are the recommendations that are most suitable for your depth of 0 to 20 centimeter. Because like, as you can see, you have your, on the crop side, can you see we have the bananas, avocado, mango, pecan nut, and macadamia. The fertilizer recommendation or the interpretation with regard to this one. Because like, for example, an avocado, it can take years to be at its stage of saying it will bear fruits, or you can start to harvest your fruits. So it means that the fertilizer recommendation program is going to be different, because you have to fertilize at the age of your plant at the first month of establishment, and then after you will have to make another program of fertilization, maybe 6 months, after 6 months or 3 months program of fertilization. Okay, it's fine. Now let's check on the part of the grains. Let's check our results from Noitgedacht. Let's say now we want to plant maize. If we check on the results of Noitgedacht, the results are saying we are having pH of 5.6 and then KCl 4.3. Can you see that on the table? It says that on this table, it says that for the grains, at least the optimum pH, if it falls within 5.5 and 7.5, at least you are on the safe side, the pH of water. You are on the safe side to do what? You can plant your maize. However, we know that soils are not having the pH that we want ourselves. So if the pH it is not suitable, obviously you are going to do what? You are going to manipulate that soil and then make it comfortable. For example, the results that we are having from net reduct, step number 1, the pH, is it okay for production, for maize production? Is it a yes or no? Then we tick a yes, right? And then now we go to phosphorus. Phosphorus from net reduct results, you can see the value, it is 6.29. The value that we are having here for grain production. For grain production, you will require phosphorus at a level of 15 to 30 ppm or milligrams per kilogram. You can even see here it is written. These values are in ppm or milligrams per kilogram. Can you see that according to the results of net reduct, the soil has low phosphorus, and it means that already we can see that we are going to buy a phosphate fertilizer. And then now let's come to our potassium. From the results of net reduct, if you see the value of K, the value of K, it is 41. But as you can see on the table, for you to get at least the approximate optimum production, your potassium must be 80. And then let's come to calcium magnesium. At least our calcium magnesium, specifically for the grains, the values, they have to start from 300 ppm to 2000. According to the results that we have from net reduct, the value here, you can see it is 270 something. Can you see that now these soils, they are not, the only thing that has passed here is only pH. Phosphorus, it is very low, and then potassium, very low, calcium, very low, and then now let's see magnesium. Magnesium, it has to range between 80 and 300. According to the results, what we are having, it is 4.6, right? Can you see what is happening?
Yep.
Yes.
Yes. Then, okay, it's fine. Now we have, in terms of, I'm not yet at fertilizer recommendation. I'm just interpreting the report. Just interpreting this report, the results that we are having from net reduct sample number A, we can see only the pH, it is suitable, and then phosphorus low, potassium low, and then the calcium magnesium very low for maize production. Okay, now let me move forward. Now, these are some of the norms that you will need when you are making fertilizer recommendations. So this is one of the table that in most cases when I refer using these tables, because like, for example, if you can see here below the table on NB, to calculate these ratios to milli-equivalence values must be used not in milligrams per kilogram. Then you will have to convert these values of your results. You have to convert them from the milligrams per kilogram or ppm. You convert them to C-mol per kilogram of a soil, or you have to convert them into milli-equivalence. And how did they do that? If you can see, we are having for our cations from this conversion. You have the conversion factors. These conversion factors, someone can ask me, where did they get this 391? Where did they get this 200? Where did they get this 122, this 230 and 90? Ladies and gentlemen, if we can go to the periodic table and then you check calcium and then you go to magnesium, can you see that on the periodic table magnesium is 12, right? Magnesium is 12, or it can be 12.2 something. And then you're gonna take the valency, or you are going to take the valency on the periodic table. If you can check your calcium and magnesium on the periodic table, they are on group 2. These are group 2 elements on the periodic table. And then what you are going to do is you are going to take the atomic number and then you multiply it by 10. And then remember, calcium and magnesium, they are divalents. So the ionic form, it is 2+, magnesium 2+, and then sodium 1+, potassium, and then 1+. So these are the factors that they got from the periodic table. So in most cases, when you want to convert, or when you want to calculate the CEC, the ion exchange capacity. You have to calculate the cation exchange capacity, and then you have to make sure that when you check that effective CEC, you have to convert them into from milligrams per kilogram to C-mol per kilogram. So these are some of the calculations that maybe on your spare time I can show you from the periodic table, and then I will explain what is happening. Then it's fine. Number one, I'm still on the Noit Redact soil testing report. Remember, now you have found that your soil in general, it is acidic, right? Now, that's where we are starting to write our notes. Number one, our pH of this soil report are acidic. And then now let's check the issue of liming. And we are only going to put lime so that we make sure that we correct. But according to what we have seen, we can see that these soils, already the pH, at least it is acceptable. But we are worried about the issues of calcium and magnesium. So at least we have to up the issues of calcium and magnesium so that they can suit the range that I was talking about. For example, now this is how you are going to check your lime, because these soils are acidic. For us to check if this lime is calcitic or dolomitic, this is how you do it, ladies and gentlemen. And then you are going to open your book, your Fertasa book, and then you are going to check on the table of content where they are saying determination of lime and whatever, and then you will find this table on that book. And then what we are going to do, let's check our Noit Redact soil testing lab analysis. What we are going to do, this is the graph of magnesium analysis versus calcium and magnesium to ratio. Then how do we decide if our soil need calcitic lime or dolomitic lime? This is what we are going to do. For example, on our results, the magnesium, it is 46.24. If you can check on the y-axis, ladies and gentlemen, can you see that 46, it might be somewhere around here of magnesium or somewhere here? Can you see?
Yes.
Yes, and then now let's check our values of calcium and calcium. The value of calcium, according to the Noit Redact soil testing report, it is 273, and then magnesium, it is 46. Then we check how many times does magnesium go to calcium. Then we are going to say 273 divided by 46. Can someone give me an answer very quickly?
6.
Okay, the value, it is 6, right? So it means that magnesium goes 6 times into calcium. So what we are going to do, remember, I'm sorry about this. Remember what we are going to do. Now we checked at the magnesium analysis, it is at 40 something. And then now it goes, magnesium goes 6 times into calcium. This is calcium to magnesium ratio. So it means our ratio, it is 6 is to 1, right? Then you are going to draw a line going upwards. You are also going to draw a line where they intersect. This is where you know this is the type of lime I am going to use. That's why you will find that on an analytical report, it is very much important for you to have an analytical report that is having the cations. It will help us to know the type of lime that we are going to use. So we are going to agree as a group that the type of lime that we are going to use for this analytical report, it is going to be a dolomitic lime, right? Now we are done about the type of lime. Another question that will follow is to say, okay, we can see that we are going to use dolomitic lime, but the quantity, how much are we going to apply this dolomitic lime? And then now we are going to use a table that says lime requirement according to the soil pH, KCl, and texture, right? And then now we are going to determine lime using the pH of KCl and the clay percentage that we got from the report. If you can check the pH of KCl from the Noit Redact soil testing laboratory, it is 4.3, right? Can you see, ladies and gentlemen, the pH of KCl, can you see that it is 4.3 on the report, on the Noit Redact report?
Yes.
So immediately when you are checking this pH of KCl, if any analytical report comes with a pH of KCl and that pH it is 5, it means that there is no need for liming. Can you see that the only time when we need lime in the soil, it's when your pH of KCl, it is at the value of 4.6. Can you see? If you have an analytical report, you find that your pH of KCl, it is 4.6 going downwards. Just know that lime it is needed. Now we are going to use this table of a relationship between the clay percentage. If you can check on the Neutgedacht soil testing laboratory results, can you see that we have the percentage clay? The percentage clay here, it is 8%. Can you see? So what we are going to say, we are going to come here on this table, we are checking the clay percentage. If that soil, it is having clay percentage that ranges from 7 and 8, we are going to use this line. And then we check where it is our pH. Can you see our pH, KCl, it is 4.3. So the intersection, it is 1.5. So it means that we are going to apply 1.5 tons hectare of dolomitic lime for these results. Can you see what is happening?
Yes.
So it means that we are done with lime. This is how you determine lime, because lime, it is all about calcium and magnesium, and also the most driving factor, it is the pH value. So if you see that pH of KCl being 4.6 going downwards, just know that we are going to lime that particular soil. So can you see that even at the same time, let's say, for instance, there is an analytical report, exchangeable acidity, or maybe acidity was not really determined, we still have another alternative way of knowing that this soil really need lime. Can you see? Then now it's fine. Now what we are going to do, ladies and gentlemen, we are going to make fertilizer recommendations on maize production. So in most cases, if you can read the theory everywhere. They will always tell you that the production, any production, it can be a grain production or a vegetable production and whatever. But now let's focus on the grains. We are going to make fertilizer recommendation using the very same results of Neutgedacht, right? So when you are making fertilizer, there is a statement that I want to make. You should note it down. There is a huge difference when you are making fertilizer recommendations for maize and vegetables. So when you are making fertilizer recommendations for maize, this is what you are going to do. You are going to go on your table of content or on that brown book, and then you will see it will be written maize production, and then you will find this table. So in most cases, the most critical part that we do when we are making fertilizer recommendations for maize, ladies and gentlemen, if you can see, or if you have moved around, in most cases on the large scale farming, most farmers that are dominating in maize production, they always have or they always do soil classification. What they do is they will always dig a soil pit and make soil classification to get the soil type, or they will drill an auger to check the depth of the soil. So maize production, since it depends on the rain-fed conditions. So if, let's say, now you want to make fertilizer recommendations for maize production, where you know that you do not have the irrigation system, you are going to depend on rainfall. This is the information that you need for you to make a fertilizer recommendation for maize production and be able to get the target yield. In most cases, what you need, the first thing that you must know is the amount of rainfall that you receive per year in that particular region, right? Now, we are going to say this for our analytical report. Let's say we assume that for the analytical report that we are having, let's assume that this analysis belongs to the area from Limpopo. If that area from Limpopo is a semi-arid or an arid region, if it receives the amount of rainfall 500 millimeter per year, it means that when we want to check the potential yield, we are going to be guided by what? We are going to be guided by the rainfall. You cannot go and aim the target yield when you are going to depend on rainfall, and then you go and make such a huge or a high amount of target yield. You are also guided by the rainfall. if you make just any higher amount of target without considering the issues of rainfall, without considering the issues of depth, you are going to have a problem on your production. So one thing to note down is when you are making fertilizer recommendation for maize production, you have to be considerate about the rainfall condition and also the soil depth. So if you can check, there is a relationship between what we are going to do. We are going to determine the potential yield according to rainfall and soil depth. So for example, we are having a solid rock or a hard plinthite. So these are soils that in most cases, when you are digging or when you are drilling an auger, before you reach maybe a depth of maybe a depth of 1 meter, there is possibility that you might find a bedrock underlying after the topsoil. Maybe you are Mispa, for instance, or at some point maybe you are Glen Rosa to that extent. Can you see? And then now let's find, or let's just assume that let's just assume that from our results at Noitredacht, the rainfall, it is around 500, and then the depth of that particular soil, let's just assume that it is between 1.2 meter, right? So it means that if your soil depth, the limiting or the effective rooting depth, it is 1.2 meter, and then the rainfall, it is 500. So your target yield should be 2.5. You cannot be in a condition whereby your soil depth, it is 1.2 meter, and then you go and target 10 tons per hectare, whereas the amount of rainfall you receive is 500. So from now on today, you learn that when you make target yield, it should go with the relationship of what the amount of rainfall that you receive as well as the depth. So according to the results that we got from the Noitredacht, we are assuming that this is the depth. I mean, this is the target yield that we are going to use, because we have agreed that let's say the results that we are having, the amount of rainfall is 500, the depth, it is 1.2. So our target yield, we are going to make fertilizer recommendations based on the target yield. And one thing that we have to know, ladies and gentlemen, there is no way that you can make fertilizer recommendations without having a target yield. The target yield is the very first thing that we have to know when you are making any production. It can be tomato or whatever, but you must have a target yield. So now going forward, I believe that we took 2.5 as our target yield. And then now let's come back to that result, and then we check. This is how we are going to make fertilizer recommendations. And then we said from those results that we got, if you can check, we are going to use the relationship between clay percentage. So we are going to use, if you can check, this is the table of nitrogen guideline adjusted for according to the University department. So what we are going to do is we are going to use the texture versus the target yield. The target yield that we got, it was 2.5, right? So if the target yield that we got, it was 2.5, it means that we are going to say 2.0 plus 3.0, then we divide by 2. Obviously, we are going to get somewhere around here. And then our target yield is somewhere around here, 2.5. And then now our clay percentage is in between 15 and 25. We are going to say 15 and 25. And then if we take this one and this one, then it means that the nitrogen that we have to put, it is 10. I mean, it is it is 10. The amount of nitrogen that we have to put, it is 10. And then from there, it does not mean that we are going to put 10 bags of urea, or we are going to put 10 bags of LAN or 10 bags of 232. I'm still going to show you how to choose the fertilizer type and how to put this, the estimated recommendation of 10 kg per hectare.
Mr.
And then
Sadiki,
now, Yebo.
are you still using the 8% clay content?
Sorry, yes.
So it's between 5 and 15, not 25.
Yes, yeah, I'm sorry. Yeah, between 5 and 15. So it means that we are going to take 23 plus 10 and then we divide by 2.
Okay.
Yes. And then now let's move to fertilizer recommendation. This is fertilizer recommendation for phosphorus. So our results, if we can check from the lab, the results was how many? It was 6, right? Was it 6? The
Yes, it
result
was
was
6.29.
yeah, it was
6.29.
6.29. So it means that we are going to check here. The values, our value falls around this category. And then at a target yield, can you see, we will have this target yield until. So our target yield is in between. So it means that what we will need is gonna be 20 plus 42 because it is in between. Then 20 plus 42, we add, we divide by 2. The value that we get, we put it in our mind that this is the P that is recommended. And then now let's move to potassium. I'm still going to show you the number of bags, how do we calculate the bags and whatever and stuff. And then now let's come to potassium. So there are two different types of tables. So this is the table that we are going to use only if our clay percentage is lower than 25%. Then according to the results of net reduct, our table, if you can check the results, it is 8%. So it means that we are going to use this table instead of table number 2. This table number 2, we use it when the clay percentage it is greater than 25. So now let's see, according to the results that we are having, the target yield is in between here. And then now the results from the lab, it says it was how many? 41, right? So 41, it is between 40 and 60. Then we are going to come here and then 40 between 60 and then we go, and then we can just use 5. I think it is best if we can use 5 because from the interpretation there, it showed that our potassium was very low. So now, what are we going to do with this value of, for example, 5, and then the other one that I just selected from these 3 tables, number 1, number 2, number 3. Now this is where fertilizer recommendation comes. I'm not sure if I can you see my screen? Can you see the screen?
Yes.
Okay.
Yes.
Okay, these are the types of fertilizers that we are going to use. I just selected few of those. We have single fertilizers. You have your LAN as a source of nitrogen at 28%, urea 46% as a source of nitrogen. You have single superphosphate. It might come at 8.3% or 10%. And then after, I forgot to put the source of potassium, NPK. K for potassium, we can use KCl 50%. It's a single fertilizer, that one. And then in terms of mixture, we might use 23230 or 23222, or you can use 43440 or 43444. These are the fertilizers that we are going to use. And then now, I'm not, can I quickly, Dr. Sandile, get into my program and show you how we do this fertilizer recommendations? Quick.
No problem, sir.
So is everyone able to see?
At the moment, we
Are we
can
able to see now?
Okay. Yes,
Okay,
we can
it's
see
fine.
your spreadsheet now.
Now, this is the spreadsheet. Okay, it's fine. I'm sorry about
Is it
that.
possible to enlarge it a bit?
Okay, yeah, I will do enlarge it. And then one thing that I have to mention, we have, okay. Are you able to see?
Yes, we can see it now.
Okay, this is a spreadsheet number 1. So this one, you use it manually, referring on the guideline on the book. But now we have another spreadsheet whereby we just take all the all the analytical results, we just paste them all, and then it calculates and gives us everything. So if you remember, what you are going to do now, for example, I said for single fertilizer, we are going to use LAN 28%. For phosphorus, we are going to use a single superphosphate. For KCl, we are going to use, for potassium, we are going to use a 50% KCl. So what I was doing on that activity for nitrogen, when I was saying, for example, let me go back very fast, and then we are going to choose. Can you see that we said our clay percentage was somewhere in between, and then for 2 tons per hectare, for 2.5 tons per hectare, we have to say 23 plus 58 divided by 2. What is the value of here? 23 plus 58 divided by 2. What is the value? For sure, it has to be 30 something. or 40? Can we say 40?
41.
Okay, 41, it's fine. Then if our value here, it is 41, what we normally do, it means that the requirements, it is 41, right? We only put here on the shaded part, on this green shaded part, I'm going to put 41, and then the spreadsheet will calculate. And if you want the manual calculation, I can still have a spare time and show you how do we do it manually. Now time has advanced. There is no time for me to calculate one by one. I just have to put these values here. The spreadsheet calculates everything, and then we get the results. We move on. Then now for phosphorus, can you see?
Sorry, Sadiki.
Yes.
But when we're doing it manually, you're still going to use that formula whereby saying mass of fertilizer is equal to nutrient recommended, then divided by, you're using that formula.
Yeah, that formula dividing by nutrient percentage.
Oh, no problem.
Yeah,
thanks.
because, okay, if you can see on the slide, right? I just want to show you a quick example. Can you see on the slide?
Oh, no. Yeah, no. That's this. Yeah, no.
Yeah, this is the formula. This one is for a mixture fertilizer when I'm doing it, and then these are the calculations. You know them.
Yeah, no, yeah, the same formula that I know. No,
yes,
thanks,
yeah, this is the same formula. So we made things to be very much easier. Now we have a spreadsheet. You do not have to calculate one by one. You just have to refer to the table, and then you go to that table. You said the value is 42, right? 23 plus, you said 42. Then we put 42 here, right? And then for potassium, let's go to this table. Let me see. On potassium, what did we say? Potassium K, it was between, is it 40 something? And then somewhere around here. But in most cases, when it says 0, it tells you that on the spreadsheet, you must put 0. But let's check the value between 40 and 60, and then we come here. Let's say we put 5 for argument's sake. At least you have to put something. Now we come back here, and then we put 5. Then after putting 5, the spreadsheet will calculate everything. And then what the farmer is really interested in is the recommendation comes back for this fertilizer recommendation to say you are going to apply 230. You are going to apply 7 bags. So let's say now a farmer has already bought a fertilizer of 434, and then you are having this spreadsheet. Then what you are going to do now is you are going to adjust according to what the farmer bought. For example, we are going to change the ratios of the mixture compound. 4, 3, 4, and then 434, 33 fertilizer. If you can check at first, it was 7 bags. Can you see now? Now it is 9 bags, but when it comes to the single fertilizers, LAN or KCL, it is minus. So it means that with this one, you just apply at once. Can you see? It will depend on because like the ratios are not the same. Now let me say you have used 43440. For 43440, and then let's say we adjust here 43440. And then let me check, because remember this 40 is the active ingredient. So it means that in that 50 bag of 50 kg bag of fertilizer for 434, there is only 40% that is going to be divided into NPK. Can you see? Now we have increased the percentage. Now it is 8 bags. It is no longer 9 bags. Now let me come to the new and improved spreadsheet here. We are going to check on our Neutge duct soil testing lab results. I'm just going to punch everything on the yellow shaded part, and then the spreadsheet will calculate everything for all the crops. For example, it is going to calculate for beetroot, it calculates for cabbage, for carrots, for chilies and maize and everything. So now let's put those results of Neutge duct, and then we see. We said the pH of KCL, it is 4.3. And then calcium, what was the value of calcium? The value of calcium was 273.5, and then maybe I can just say 2 274. And then magnesium, the value was 46. And then sodium, the value was 12. And then potassium, the value was 41. And then now phosphorus, the value is 6. Let me just put 6 or 6 point. It was 6.29. It's fine. But just because I did not put commas in these ones, and then I will just give them just a number like this. And then on this one, the clay percentage was 8. And then in most cases, can you see on the spreadsheet here on the texture, it is written that it is false. It is false because like we are not having the clay percentage. Let's say if this one it is 8, the silt it is 2, and then the silt it is 90. Then after punching, can you see? It tells you that now your soil it is sand. We have computed this spreadsheet using the textural class that you find. There is another textural class whereby after when we analyze our clay percentage, we just put the values and then it calculates as well. And then we just combined it with this one. It will tell you. You still remember on our calculations with these values, I said is going to be dolomitic at 1.5. Can you see? The ratio, if you still remember, we said it goes how many times? 6:1. Can you see?
Yep.
Yeah, it goes 6:1, the lime requirement. And then now we can still play around the mixture compound here. If it is 232, now I will just take an example with something like beetroot. Can you see beetroot, for instance, for mixture, you will need 43433, 22 bags, LAN -2, I mean, a KCl minus, it means that you do not add anything. Now let's try to check to change the compound fertilizer. 22 bags when it is 434. And then now let's see when it is 232. 232, let's say 22 or 23230. We put 23230. Can you see now it is 16 bags, but now you are going to add the single fertilizers. You see, you are going to add LAN, you are going to add KCN. So this is how we normally do fertilizer recommendations. And like that process of calculating using the old way, just imagine when you are doing these samples one by one, making calculation like this. Just imagine one by one. So on those 232, let me just explain something. For example, if your fertilizer mixture, it is 23222, it means that in that particular 50 kg, on this 22%, if you add this one and this one and this one, they will give you 22. You can see that from nitrogen, it means that it means that in the 100 kg of a mixture, there is 6.2 kg of nitrogen that is supplied by that fertilizer. And then this one 9%, this one 6%. That's why you see the ratio is 232, 2. So this one and this one must balance. This one must be the same and this one. So it means that in a bag of the rest, in most cases, you'll find that it comes as 232 plus 5% zinc, but the rest, it is just a carrier. And the carrier in most cases is just the talc. That material, in most cases, it can be a calcium and magnesium lime, but at a lower percentage. That lime, it will not be more than 5%. It's going to be at a very, 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 very low percentage. It's just a carrier, you see. And then that comes to the end of my presentation, because it will take time. Maybe slowly by slowly we can do fertilizer recommendation for vegetables and whatever and stuff. But I just chose maize because I thought it was very critical because of this table. This table is very much important. For maize, it is not the same as we are doing fertilizer recommendation for the vegetables. And this is how you really make fertilizer recommendations. For example, there was another table here of the how you convert from, or how do you come about the issues of calculating your CEC. So this is how you calculate your CEC, your calcium, potassium, magnesium, and whatever. This is it's only effective CEC. You know that a complete CEC, it should have aluminum and hydrogen, because you are having the basic cations and the acidic cations. All of them, they form CEC. Then if you just calculate only the cations, you have calculated the effective CEC. It is not complete. So this comes to the end of the presentation, ladies and gentlemen. So unfortunately, this one, it has to be practical. We had to check the report and then we refer using the report. Thank you very much.
Thank you very
Thank
much.
you.
Thank you very much, Sadiki. Thank you. I see we have two hands.
Yes.
Adolphe and Colin, in that order, please.
Thank you very much, Chairperson. I think I must say to Sadiki, I appreciate the opportunity to listen to you and hear your experiences. I just wanted to find out from you, the tables that we're sharing on the guidelines, are those tables applicable on both Lowveld and Highveld, or I sense that they are more relevant on Highveld?
This one, Mr. Malachi, for example, let me come here very quickly. So now, for example, the issues of Highveld and Lowveld, in most cases, we would know that for the fact that we have classified that we have a Highveld and we have classified that we have a Lowerveld, somehow the issues of rainfall were considered to say this one, it is Lowveld because it receives this high the amount of rainfall and whatever. But I also consider what you are saying, the issues of saying Highveld and Lowveld, because I remember when we were doing that table of classifying production on the Highveld and also classifying production on the Lowveld. So unfortunately, I just chose only this table. Then on the new book, this one of 2016, you have an opportunity to make fertilizer recommendations for the rain-fed conditions and also for the irrigated part.
Okay, thank you, Sadiki. I saw Colin, you had your hand up.
Yes, my hand is up. Yes, and thanks for the wonderful presentation. Even though it doesn't need just 30 minutes, it needs at least a week of interpretation and interrogations. So I wanted to check with you with regard to the pastures. Have you ever had any analysis based on the planted pastures yet?
Yes, Mr. Rabutata. The norms or the critical values for fertilization of pastures and fodder crops are there on this book of Fertasa or Fertilizer Handbook. If you go to page 263, if you are having that book, there are tables that we use for fertilizer recommendation. For example, we have your lucerne, we can do that, your ryegrass, your Nile grass, tall fescue, elephant grass, rose grass, and whatever. Yes, we can still make fertilizer recommendations on the grasses. These kind of tables are there on the book. We can still make those. We have norms. It is possible.
Okay, no, thanks very much. I think that will ease our job also on our side.
And we also have them for the perennial crops and also for the cool season crops. Like all the tables are there. If you want to do for the perennial crops, we have the norms. And then if we want to do for the cool season or the annual ones, and then the tables are there. We can make fertilizer recommendations. Thank you.
Okay, thanks very much.
Thank you.
Any other question or comment, colleagues?
I don't know, Doc, but I don't. I didn't hear the sense of different colors like maize, different cultivars, or is a minute parameter, a factor on fertilizer requirement.
Okay. All right. You are checking the issues of variety. If ever these fertilizer recommendations or the we can adjust these fertilizer recommendations based on the cultivar.
Yes.
Yeah, this one, unfortunately, this book from 2007 and 2016, they were still using some, these norms have been collected a long time ago. So it means that I'm just with my own thinking, I'm just thinking that in terms of the variety and whatever, to say like which cultivar can perform at this depth or which cultivar can perform at this depth, I do not have such information. But to my advantage is last week I was attending another presentation. I was told that for maize, each and every year there are new cultivars, or like there are new cultivars whereby they are trying by all means so that they can get cultivars that are adaptable to stress conditions and stuff. But this fertilizer recommendation is just generally for a maize without checking the variety, which variety.
All right, thanks, sir.
Yes.
Colleagues, in the absence of questions or comments,
I've got a question. Sorry.
Okay, all right. I see. Before Colin, before I give you a chance, Colin, I would like to give Vusi an opportunity.
Okay. Okay.
Thank you, Colin. Vusi.
Thank you, Chair. Mr. Sadiki, sorry about that. I was distracted
Okay.
for a few minutes, so I think I was lost somewhere. I was on another call. But
Okay.
you may have covered what I wanted to ask. You will pay me out if you did that.
Yes.
Just two quick questions. The first one is on you. I'm happy that your presentation was very technical, I must say.
Yeah.
But very much full, which is fine. I just want to find out on the issue of the spreadsheet. I was happy that at the end you actually managed to say that you guys do use this spreadsheet to do calculations other
Yes.
than the manual stuff you showed earlier. But
Yeah.
one thing I didn't see was with regards to when you are on that stage of fertilizer recommendation, is your spreadsheet able to tell, for instance, ideally you will start with the most expensive fertilizer in my understanding, which is normally phosphorus. So,
Okay.
so for instance, let's say you using your diammonium phosphate, and then somehow while trying to address the deficiencies of P, obviously based on your results, and then you find that there is surplus of N. I'm sure you can get what I'm talking about.
Okay.
Because diammonium phosphate, it also comes with nitrogen, isn't it?
Yebo.
Yeah, so is your spreadsheet able to accommodate such, to give you like a warning light to say, listen, as much as you are trying to do justice for P, but you are now actually tampering with your N, it's excess. Does it accommodate such?
No, unfortunately, Mr. Mbanjwa, on this one, we chose only LAN, and then we also chose urea as a source of nitrogen. And then the reason why we have diverted from that one, we knew that it comes with two nutrients at the same time, and it will require time for us to calculate the surplus to say like how much it is left. Because if you can just use, in most cases in our farmers, or when we are making fertilizer recommendations, we prefer to start with the mixture, so that we know that, okay, from this mixture, if the soil can, if the fertilizer can be able to cater for 1, 2, 3. In most cases, you'll find that the surplus, it is phosphorus, and also at some point it can be potassium. Then that's when we would advise to say, go and get that single superphosphate. You
okay.
see, we do not on this spreadsheet. Unfortunately, we only focus on this one so that we must be accurate in terms of the amount of nutrient that the plant must receive, to avoid the issues of over applying or under applying. So we just only selected this. And one thing, we have another spreadsheet. Sometimes we use urea, sometimes we use LAN. For example, if you can check, can you see on the spreadsheet now?
Yes.
If I press 7 here immediately. Okay, let me check. Let me check 7. Let me check. Yeah, can you see? Let's say now your pH, it is 8. If your pH, it is 8, now the spreadsheet automatically changed to urea. We only used these two types of nitrogen fertilizers, the LAN and the urea. So in most cases, we do not recommend to our farmers to apply LAN, more especially if the soils are alkaline. Because like LAN, remember, it is lime ammonium stone. So it means that at the same time, LAN will do what? Will also contribute to the pH going up. But instead, in most cases, when the pH it is up, we recommend our farmers to use urea so that it can help in terms of suppressing the pH. Bearing in mind that you know that urea, it produces some acids as compared to. But in general terms, I understand that all fertilizers are acidic, but the level of acid that urea produces because of the presence of hydrogen on that equation, it poses the issues of contributing to acidity. So in most cases, if your soil are alkaline, for source of nitrogen, I normally advise if someone can use the urea. Or in most cases, if they want to use ammonium sulfate, I know that that sulfate is going to assist in terms of suppressing the pH.
Okay.
Yeah.
No, thank you for that. I think, Dr. Mtunko, you wanted to follow up?
But when you're done.
Oh, okay. The last question is about the output of your results. Do you also indicate the permissible acid saturation depending on what crop the farmer is interested on?
No. We do not really reach that stage because, like, for now, there is a lot of information that I'm having, but just because of time, that's when most of the time, like, I do not touch base on them and whatever, because like ideally, honestly speaking, if we can check now on this analytical report, this one, the note reduct, what we are analyzing, can you see the standard package that we are analyzing? But now we know that in Mpumalanga, most of the soils are acidic. We were not supposed to be to be checking electrical conductivity, but instead we were supposed to be checking a aluminium exchangeable aluminium or acidity. Yeah, we were supposed to be doing that because we know that most of our soils that we receive are acidic, but because of the because of the limited chemicals and apparatus, that's when I just said, okay, it's fine. I cannot just release this report not having at least something of an indicator. At least with electrical conductivity, it shows that the soil content is very low, and it will also support the argument to say indeed the pH it is very low. But moving forward, more especially next year, that's when I was thinking that because we plan according to the financial years, that's when I made a lot of procurements to make sure that going forward, I'm no longer checking electrical conductivity on acidic soils. I will be using I will be considering that one as well.
Oh, okay.
Yeah, it was just because because like one thing again, if you can check onto this table, can you see that for example, let's say now you are checking your base saturation. With your base saturation, for example, what you normally have, it's 100 multiplied by S. S is your cations, and then T, it is the CEC, whereby hydrogen and aluminium, it has to be there. And then now to get your acid saturation, and then what do? Your acid saturation, it is what? 100 minus the base saturation, and then you get it. And then there is another formula that was indicated there, like how do you really check on it? Because I think we can, if you have some time, we can discuss that one. I will show you how to get it. It is very much easy to get that one. Very, very, very easy.
Okay, because my concern was that it will be nice to actually see what the acid saturation percent of the soil, of the farmer's soil is. And then you also have a column next to that which shows the permissible acid saturation of that crop. Then the farmer can see.
Yes, you are definitely right on that one. I already took it into consideration, because it's just that because of these things of the budgets and everything, I just said, like, because I'm not having those, and then because in most cases I once went to ARC to check how it is calculated or how it is determined, and then the simple method you can use the titration method. So the problem is I want to get the auto titrator so that when I do titration, I do not use my hand, because you know that when you are checking acidity in the soil, immediately when you just open your burette, immediately there is a color change, and then that color change, you do not know whether if you have over pipetted or not. So if I get that equipment, and then I'll be very much happy. But my procurements are underway. Maybe next year you will see my report having it.
Oh, no problem. Thank you very much.
All right, thank you very much.
Thank you, Felix. Thank you very much. I'll go back to you, Sadiki.
Yes.
Oh, yes. I know that we've gone over our time. And I see that Colin has his hand up. I think I will allow him, but I see it's most of the colleagues, some of our colleagues are leaving now. I think it's because of the time.
Yeah.
But, Colin, I will give you a chance to speak.
Okay, I wanted to check with the liquid fertilizer. I've been seeing an advert on a fertilizer called Guano Boost.
Oh, the Guano Boost.
Liquid fertilizer. I don't know how are the percentages in terms of the potassium and calcium and other stuff. Do you have any idea?
Okay, on that guano, I just saw it online on the advert, but my advice is that in most cases, all those liquid fertilizers that you may know, they always put the nutritional content values. They put that they will put it. As long as they are selling that product, they should be, I just assume that they should put the nutritional content value
on the label.
Yeah, on the label, or unless maybe if that guano is made of the organic microorganisms and whatever. I don't know if it's, but somehow, even if it is organic, somehow the nutrient content for nitrogen and the potassium or zinc and whatever, at some point they must be there. They have to be there. We have to know.
Okay, no, that was just my interest for now. I'm coming.
Yeah, but that one, when it comes, obviously, because it's liquid, you will find it, it will come in percentages.
All right. No, thank you. Thank you very much, Sadiki.
All right, thank you.
Thank you so much. That I wish we had more time. I wish we had more time because I actually had a few questions that I would like to ask you, but maybe because I cannot ask those questions because of time, there's something that I would like you to pay attention to, maybe think about.
Yeah.
When you're deciding which nitrogen source you're going to use. I heard you talking about, I mean, when you're choosing between LAN and urea.
For top dressing.
Yes, for top dressing, and you're saying that if the pH of the soil is high, you normally use urea because LAN has got that liming effect. What I would like you to think about there is the loss of nitrogen through volatilization.
Yes.
From your urea. So as to how that how the soil pH affects the loss of nitrogen through urea. The loss of nitrogen through volatilization from your urea. Maybe it's something that you might want to think about. There's a lot of work that the sugar industry has done on that. So you might want to think about that. But I mean, we can talk even after this. About that.
Yeah. Like you are definitely right, doctor, because before, like when it was when we were about to make the choice of saying let's use urea in land because of this advantage and the advantages or disadvantages between the two. So what we really did, we chose that one because we thought of the effect of that acidity. But somehow, I really read a lot around between urea and LAN. But most of the results, they were favoring LAN for those reasons. That one
yes,
I
actually,
do acknowledge.
Yes, that's the thing.
I saw a paper from Omnia. Even if you can go to Omnia page, I think there's someone who wrote a study and then the article it is there.
Yes, actually, the reason I didn't want to spend too much time on that.
Yeah.
But if you look at what they're doing in the sugar industry, they even have a parameter. They call it N volatilization. It comes in it's expressed in a percentage.
Okay.
So they're using those things to sometimes decide on these things we're talking about. I don't want to dwell on that too much for now because of time, but I think we'll talk after this at some point. All right. So colleagues, I think I just want to, let me see. Yeah, there's very few of us now. Thank you. I think I start by thanking